Hello, and welcome to a little video about Target 5A, I almost said 1A, Day 2. Alright, so we're going to be talking about substitution in this video, but I do want to go over a couple other things. First of all, I wanted to go over how to look at graphs and understand solutions. So in number 1, we have 3 graphs, 2 of which have solutions, 1 does not. Let's take a look. Letter 1A, has 2 lines that cross each other. This means a solution exists, and the solution exists where those lines cross each other. They cross each other at the point 3, 0, because it's 3 on the x's and we didn't go up and down on the y's. Letter B also has a solution. We have 2 lines, they cross each other right here. Well, let's decide on that point. The way we do it is we look at the x first. So that's 2. And then we look at the y, 4, 2, 4. So there are 2 solutions, or at least there's 1 solution for each of these. Letter C, on the other hand, has 2 parallel lines. Parallel lines do not cross. Therefore, they will never have solutions. So there's no solution. So looking at these types of graphs, this is how we understand, by these types I mean a system of 2 equations. If we look at those graphs, we will see whether or not we have solution or we don't. It's a bit hard to see if we have a infinite solution because, well, I'll show you in the next part. Now, there are 3 types of solutions, 2 of which we looked at already. Case 1 is 1 solution. That happens we have 2 different slopes, the lines cross each other. The other type of solution is no solution. Algebraically speaking, they're the same slope, different y-intercepts, they're parallel lines. They're never going to cross. The third case is infinite solution. Now this is a little bit silly to look at, but because it looks like 1 line, but really it's that red line and a blue line that I have on the other 2 pictures, but on top of each other. The slope is the same, the y-intercept is the same. Sometimes, we get the same equation twice, and it's very obvious. So like you'll have y equals 2x plus 3 and y equals 2x plus 3. That's very obvious that it's infinite solutions. Other times, we will have equations that are doubled or tripled. That also means infinite solutions. Let me show you. Here's an algebraic case of both. All right. First, let's take a look at number 2. Number 2, let's compare the slopes, because that's what we look at first. If we have different slopes, automatically 1 solution. Same slopes, that means we're going to go somewhere between no solution and infinite. We're going to have to decide which. All right. So for number 2, the slopes, which are the numbers in front of x, are 4 and 6. The slopes are different. 1 solution. That means I can solve this problem and get an answer in form of numbers. Number 3. Now, number 3, we have 1 equation that's y equals, the other one isn't, so we're going to manipulate it a little bit. I'm going to rewrite my equation, and I'm only going to take 1 quick step to change it around, and that is to subtract 3x from both sides. Now, on the right side, I can't really subtract 3x from anything. I don't have any x's. So I just combine it. It goes like this, 10 minus 3x. Just tags along at the end. All right. Now, again, let's compare slopes. And then if we need to, we'll compare y-intercepts. The first equation has a slope of -3. And the second one that we manipulated also has a slope of -3. Okay. So, this is either no solution or infinite. Let's take a look at the y-intercepts. For the first equation, the y-intercept is 5. For the second one, it's 10. The intercepts are different, the slope is the same, no solution. Now, I'm pretty sure you can guess what number 4 is going to be, but let me show you anyways. Now, both of these equations are not y equals, and, oh man, it's going to take so long to manipulate them, so let's think of them in a different way. Now, If this works the way I'm talking through it, then we're going to have infinite solutions. And if not, then we'll have one solution. All right, let's see. I want to see if there's any relationship between the numbers of both equations. Now the x's, we've got 2x, and somehow, hopefully somehow, it becomes 4x. We have a 3y, that becomes a 6y, and the 6 that maybe becomes a 12. And what I mean by becomes is, I think I mentioned in the previous, when we were looking at just these cases, that sometimes it's an obvious equation with the same slope and same y-intercept. Other times it's not as obvious. You'll see the numbers being doubled or tripled, but the same thing is happening to all of our coefficients. So let's see if that holds true here. 2 times 2 is 4. 3 times 2 is 6. 6 times 2 is 12. This is going to be infinite solutions. This is the first equation multiplied by 2 gives us the second equation. That means if we graph them, it's going to be the same line. All right. Now, equations like this, or systems of equations like number 4, I will show you how to solve next week. We're going to look at equations or systems of equations that look more like number 3 and number 2. All right, let's do that. All right, number 5. What we're going to do for number 5 is we're going to substitute. When you're thinking of substituting, think about it exactly how it sounds and in terms of school. When you have a substitute, it's an adult that replaces your teacher. Here, we're going to substitute a letter. So sometimes we'll substitute a y, sometimes we'll substitute an x. We are replacing that letter with something else. Just like when there's a substitute, you are replacing the teacher with another adult. Okay. Now, in number 5, I have a y equals equation. That means I can substitute my y. And this is what I mean. Now, I like to rewrite my equations just to make it nice for my handwriting. So I'm going to rewrite that first one because I'm going to be plugging in y into that first one. And this is what it's going to end up looking. 2x stays 2x, minus 3 stays minus 3, but we are going to replace this y with x minus 1. So again, I took the y equals equation and I replaced it in that first one. Okay, let's solve it. The first step here is going to be to distribute. So we have 2x. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. And that equals negative 1. The next step is going to be to combine these like terms. 2 minus 3x is negative 1x. And the plus 3 and minus 1 just come along for the ride. Next, let's subtract 3 from both sides. And of course, let's finish up by dividing both sides by negative 1. So I get that x equals positive 4. I know that was a lot of work, but we're not quite done. We have one more little thing to do, and then learning the proper way of writing our answers. All right. We found out that x equals 4, perfect, but we have x's and y's. What I'm going to do is I'm going to take this equation, this y equals equation, and I'm going to plug in the x that we found. We found that x equals 4, so instead of x minus 1, we're going to have 4 minus 1. And 4 minus 1 is 3. Perfect. We found x, we found y, but we need to write it in a specific way. Here it is. We need to write it like a coordinate. Remember, coordinates are x comma y, so our official answer is 4 comma negative 3. Number 6. Number 6 has an x equals. That means we're going to be replacing x in the second equation. Now I know in the first one we replaced something in the first equation with something in the second one. It doesn't matter how they're stacked. What matters is, do we have an x equals or do we have a y equals? Okay, so I'm going to rewrite that second equation that I'm going to plug things into. I'm going to replace x with negative 2y and bring down the minus y and the equals 9. Now, I had some students in class ask me, why didn't you put parentheses about the negative 2y? The reason is x has a 1 in front of it. And when we multiply anything by 1, it doesn't change. So we don't really need to write the parentheses because we don't really need to multiply. So since we don't need to multiply, let's combine some like terms. We can combine negative 2 minus y. Negative 2 minus 1 is negative 3. So we have negative 3y equals 9. We don't have any numbers to move around, like adding or subtracting. All we gotta do to finish is divide by negative 3. Y equals negative 3. Fantastic. All right, we've got our y. Let's find our x. In theory, I know I didn't mention this on the previous one, but we could plug into whichever equation we feel like. I just think it's easier if you have an x equals, or if you have a y equals, to plug it in there. So we're going to plug into the x equals. We found that y equals negative 3, so I'm going to replace y with negative 3. In this case, I put the negative 3 in parentheses because the number in front of y was not a 1. Okay. Negative 2 times negative 3 is positive 6. And now let's write down our answer. 6, comma, negative 3. All right, last one, let's do it. I love this one. This one is so easy to set up and see for my students. Notice that they're both y equals. This method will also work if they're both x equals. When we have two equations that are y equals, we can start off with this true statement. Y equals y. Because it is true. 2 equals 2, 3 equals 3, 4 equals 4, y equals y. In the case of our equations, the first equation equals the second one. Well, let's do that. Let's replace our y's. That means we've got, no, I don't want to do this one on that side. I was going to do it this way. We've got negative 3x plus 4 equals 4x minus 10. Fantastic. Let's solve it. The substituting we did was replacing the y's for both. It's a very easy substituting one because we didn't need to do any distributing. I'm going to start this by adding 3x to both sides. There's so many ways you could start this though, so you could have done it a different way. I have 4 equals 4 plus 3x's is 7x's minus 10. Then I'm going to add, Then I'm going to add 10 to both sides. I've got 14 equals 7x. And then we'll finish up by dividing both sides by 7. X equals 2. Fantastic. We found x. We've got to find y. Now, it doesn't matter which equation we pick to find x. We can use either one. In the last class, I did the second one, so let's do the first one this time. I forgot to color code this part. And you know I love it. There we go. Okay. I'm rewriting my problem because, you know, that's how I like to do things. We found that x equals 2, so instead of x, I'm going to plug in 2. Negative 3 times 2 is negative 6, and negative 6 plus 4 is negative 2. That can be done way quicker in your calculator, and I know some of you could even do it in your head, so you could do it that way too. But make sure to at least write that part down. All right, let's write our answer. 2, negative 2. I hope this was helpful. if you have any questions, please make sure to ask myself or your teachers. Have a wonderful rest of whatever day it is for you. Bye!